Good afternoon, ladies and gentlemen. My name is Anton Makhinko, and I am head of the Scientific and Technical Department of Engineering firm ETOL. My aim for today's presentation is to give you information about computational aerodynamics in architectural siting or the structure of agro-industrial complex. This article presents a computer simulation procedure in Ansys SFX program for flow around the models of various cylinder configurations that schematize a silo pack. Analyzed silos, the size of which are most often built, from 11 meters to 30 meters. The roughness of the silo surface was taken equal to the height of the corrugation of the silo body. In general, the problem of aerodynamics calculation was considered in the three versions. At first, the simplest case of a flat 2D flow was examined. The height of a computational domain was taken as one cell of the finite element mesh. This is a more complex quasi-two-dimensional flow. The height of the computational domain was taken to be equal to the two diameters of the model. The last step was to perform special three-dimension flow. Construction of industrial buildings and structures requires significant resource spends. Effective use of materials is possible through rational design, construction, and operation practice, which is very important for suitable development of modern industrial construction. One way to implement this approach is to develop calculations method which must be based on accurate data. Computational simulation tools may help to obtain such data that cannot be predicted in real situations. This applies to the object of study of this article, silage packs under the influence of wind flow. Empty cylindrical silos are very sensitive to wind loads. Their determination is performed according to normative methods. There are also a lot of theoretical and experimental studies of these issues. In general, the behavior of wind currents near the buildings of simple geometric shape is well studied. However, a lot of factors related to modern silo complexes are not taken into account. It should be noted that first of all the issue of mutual influence of siloing groups has not been properly examined yet. The nature of the action of the wind flow on the silo park will be different from the action on the isolated cylindrical object. Strong suction forces, which are not taken into account in the classical calculation, arise between the silos. The silo can also be located in the area of wind shade from other objects. The second problem, the rough structure of the silo, is it has corrugated wall and a large number of stiffeners. Wind exposure to such a structure causes complex effects which in its turn will increase the load on the silo's body and the roof. For turbulent flows around a cylindrical silos, which are characterized by wide separation zone, four mathematical models of turbulence are analyzed. Comparison of calculations showed a disparity in the results up to 30% than to using different turbulence models. A parametric form was used to build a finite element mesh as well as to set the dimensions of the fluid domain in the form of a parallelepiped. In such a case, the dimensions of the mesh elements will depend on the Reynolds number and on the diameter of the silo, while the dimensions of the computational domain will depend only on the diameter of the model. The main advantage of the 2D modeling is the calculation speed. This procedure can be used for simple tasks when the silos of the same diameter are arranged in a row. Variable benchmark date are wind speed and wind direction, the number of models, their diameter, and the distance between them. The height of the silos is not taken into account in this calculation. In the problems on modeling, the flow velocity at the input was given in the form of the Reynolds number. In total, we have examined a sample of 2, 3, and 4 silos with equal and various distance between. The position of each silo was expressed parametrically along 2 axes. The size of expressed by the ratio of the peculiar distance between the centers of the cross sections of the silos to the diameter. The results showed significant differences in the behavior of the three-dimensional flow in near of silos at different initial date. For example, figure shows wind flow is a surface for 2 silos with a different initial date. For all above considered options, we have obtained wind pressure curves for each of the silos. For example, current slide shows a curve of changes in aerodynamics coefficients for 2 silos, located one after another. The nature of the placement of silos and the distance between them greatly affect the distribution of pressure on their surface. The results differ from those indicators that are taken for single structures and declared in the design standards. For a group of 3 and 4 cylinders in series, the flow pattern is similar. Another experimental variable was the drag coefficient, the value of which was also found for all the schemes considered in the modeling process. A part of obtained results is summarized in table. 3D modeling is often used when it's necessary to describe in full the actual building and near all the storage capacity. However, this causes big problems as the development of the detailed models of the silo park, taking into account the surrounding buildings and relief, is quite difficult and the calculation itself is time-consuming. In the interest of the time, it is advisable in the first instance to perform a computation of a simplified two-dimensional model of a silo or a silo park. This would enable taking a tentative assessment of the design pressure on the body and conical roof of the silo in the park and subsequent generating three-dimensional laws based on the result of the 2D calculation. Special macros and software modules should be used for fast and accurate calculation. This allows us to combine the necessary calculation procedure and to simplify them. Based on the obtained results of modeling of any type, it's possible to determine the most dangerous wind directions, perform a preliminary assessment of the calculated load, and export loads to the strength analysis program. Based on the carried-out verification test, a special technique was developed for constructing finite element meshes for the task of modeling wind action on silos. Simulation of two-dimensional and three-dimensional flow around simple silo parks at high Reynolds number has been performed. Based on the results, the studying of the kinetic spectrum and intermediate interaction of models of groups of 2, 3, and 4 silos were carried out at various angles of attack of the wind current within the framework of 2D modeling. We have obtained wind pressure curves for each of the cylindrical bodies in the group for different initial conditions. The analysis of their values has also been carried out in this academic research. It has been discovered the wind action on a silo in a silo park can significantly exceed the action on a separate silo. Thank you for your attention.